Welcome everyone to the Interprofessional Learning Network Evening Seminar Series. My name is Jo Outridge and I'm the Director of Interprofessional Learning here at the Faculty of Health, Education, Medicine and Social Care at ARU. This evening's seminar is presented by Utkarsh Gupta. He is a cognitive psychologist with an expertise in the science behind neural connections and the links to memory and self-consciousness. He is also the founder of NeuroGether, a platform where scientists and clinicians can come together to share research and expertise into clinical applications of neuroscience. As current and future public-facing professionals, it's essential that we understand how people learn so that we can support them to develop their healthy selves. This may mean learning new skills or taking on new information, as well as understanding why current lifestyle choices or habits may need to be changed. Often we have to unlearn old behaviours to make space for the new, and therefore the neuroscience behind forgetting is an important part of new learning. It may also be important for our own well-being. Tonight we have a really broad audience representing a range of professional disciplines and backgrounds, so I'm sure there'll be some interesting questions from different perspectives. So just before we get started, I want to introduce the format for this evening. We'll start with a presentation from Utkarsh, and this will be followed by some time where I will present questions on your behalf. You will be able to type questions for Utkarsh into the Q&A facility from around 7 p.m. when it will open. I'll ask the questions with the most likes first, so please do read other people's questions and use the like function to denote if someone else has asked a question that you'd also like to hear answered. So, welcome to Utkarsh and thank you for being here.
Thanks, Jo. Thanks for the introduction. Hi, everyone. So I'm Utkarsh Gupta, and as Jo already introduced, I am a neuroscientist. To further add to that, I am currently a third-year PhD student at Anglo Ruskin as well. However, I am also a module tutor and an associate lecturer for becoming a researcher module 2. So apart from my research background, I've also had my undergrad in medicine. So I do come across from a background that is very clinical. And I've always worked towards translating clinical and research towards something bigger. And then that is when entrepreneurship comes in as well. So we'll come to that later. But before that, let's start today's seminar. So is forgetting part of learning? So because my research that I'm doing here at Anglo Ruskin at the moment is a lot about memory. And what we do is we look towards the future, towards the construction of memory. But a very essential part of memory is that we need to sort of have some space remaining in our brain to actually construct those memories. And how do we have enough space in a brain might be answered by the mechanisms of forgetting. So we're going to talk in detail about what are the aspects about forgetting that we should potentially have considered to sort of enhance our functionality, not just for memory function, but also for learning, because what we learn is essentially built on those elements and basic contributions from the cognitive processes in our brain towards learning as well. So before that, I'm a very big fan of networking, and here in the bottom left corner, you would see a QR code. So that's my LinkedIn profile. I'd be very happy to connect on LinkedIn so that eventually after this seminar, if you would have any questions that you would want to ask and you would have not got the time to ask during the Q&A session, you could definitely send that question to me on LinkedIn as well. So yeah, moving on with the seminar. Seminar would be structured in this way. First of all, I would talk a little bit about our brain, our fascinating brain. But our focus would be around learning and memory. So I could also talk about my own research. And then we would see how we could translate the findings from what we know about learning and memory and my research towards what is the mechanism of forgetting and unlearning, like how essential is forgetting and unlearning for us? What are the existing theories? What are the competing theories for it? And then how we could potentially expand on it. And then basically when we would want to expand on what we have learned from previous research and theories, then we would try and see how we could potentially apply that in real world so that we have some major positive impact for the community. So Okay, talking about brain, we are in a world where technology is taking its peak, right? So when you talk about a PC, a laptop, or even a pen drive, as you can see on the top right corner, we talk about space. We talk about what is the size of this pen drive? How much space do you have in your laptop? Because what we essentially do is we take information, we store it in our devices, and then we use it for ourselves to function, to execute certain agendas that you might have had. But very similar to technology is our brain as well. So we've got the space as well. So when we talk about space for technology, say for example a pen drive, we've got a 32 GB pen drive, a 68, 64 GB pen drive. But what about brain? So brain has an approximate 2.5 million gigabytes of storage space on an average. It is still debatable. Lots of people are still researching on what the average capacity of human brain is. But for now, it's about 2.5 million gigabytes. So you could imagine the storage capacity, how evolved we are, how fascinating this little organ in our head is, and hence why it needs protection as well, hence the thick skull. So because without brain, it's really hard to function. You are here to attend this seminar because you perceived certain information and then you wanted to take an action based on that. And all of this action happens based on what is happening in your brain, how we receive different sensory modalities from our external environment, how we perceive it, and then how we relay this information into certain action, whether it's motor action, whether it's a thought process, whether you eventually dream in when you're sleeping. It all happens because you've got this fascinating brain with an amazing capacity to store information, to manipulate information, and then apply the stored information into something more creative, more impactful. So that's the big fuss about brain. That is why neuroscience comes across such a fancy science. And then when you think about the nervous system, because brain is just a part of our nervous system, but there is a bigger system that helps brain to function. So we've got central nervous system, we've got peripheral nervous system. So when I talk about peripheral nervous system, it's essentially the sensory receptors on your body or even within your organs. Then it relays to your spine, and spine essentially starts the central nervous system, which then relays information towards your brain. Sometimes the sensation doesn't really need to go to the brain because in your midbrain, somewhere around your neck, like you could potentially have some information that could be processed and sent back as well. So nervous system, including brain, is so fascinating that it could help you function, help you apply, help you be creative and innovative. To talk more about the complexity of brain, on the left-hand corner, you would see a single cell that is a neuron. A neuron essentially is nothing but the structural and functional unit of our nervous system. So I'm not talking about the whole nervous system, but I'm going to talk just about the brain. And in the brain itself, we've got about 100 billion neurons. So imagine how many small neurons we've got in our brain that helps us process what we do in our day-to-day life. On the right corner, right top corner, you would see a really colorful image of a brain-like structure. This is nothing but a diffusion tensor imaging of brain. And what if you would compare imaging when it comes to a CT scan or fMRI scan when you would have visited a hospital, or if you would scroll through a certain research article, you would see the gray matter, so the outer covering, the cell structures. But usually what you do not see in an MRI scan or a CT scan is actually the axons, the long bit of the neuron, as you could see on the left-hand side. So axon contributes to the white matter of the brain. And DTI tends to focus on this white matter and gives you a view of how immensely populated our brain is with neurons. But then it's not just that. Brain is very complex, but it's not a fixed structure. there's lots of plasticity happening. So what you could see in the center of the screen is a connectogram. So when I said that there's a gray matter, the outer lining of the brain, which consists of the cell part of the neuron, that would be the outer part of the connectogram as well. But in the middle, all the threads that you see is nothing but a replica or like something that relates to the axons. And you could see there are so many connections between the brain parts based on the axon. And then it's not just one part connected to one part can connect to multiple other parts. And then that is how complex our brain is. And you might have come across lots of companies like Neuralink or Synchron who are creating brain-computer interface to help people with paraplegia or help people with neurorehabilitation by brain implants or other sort of brain-computer interface strategies. They could tap only a little bit of this still. So it's a long way from reaching that point where we could totally decode brain. And I hope it does get decoded at some point because it will be so beneficial and could save so many lives as well. But it takes time. Technology has its own pace of development. So now you could see how complex and plastic our brain is. So, but when we talk about brain, there are so many cognitive functions that are based on this complexity and plasticity, of which two of the most fascinating cognitive processes are memory and learning, which is going to be the focus of our seminar today, and of course, unlearning as well. So what is human memory? Is human memory just an entity stored in our brain? Or is it something more? Is it a process? Is it a faculty or a system? So what we researchers think of human memory at the moment is that it's a faculty or a system that includes encoding of information, then storing of that information, and then recollection, so rather construction of a memory. So there is an ongoing debate where people might claim that memory as in its purest form is stored in brain, but some researchers, they believe that it is not just stored, but there are lots of little elements, lots of little information that is activated, and then they contribute towards creation of a memory. So it is constructed rather than just remembered. But it's an ongoing debate, and I think I am on the second part. So I believe that memory is reconstructed. It's not just, remembered. It's because if you look at memory, sometimes memories can be false. Sometimes you could make up a story. Sometimes you could have a confabulation of an event. So that is not a factual information, but it is a constructed conceptual information at sometimes. So hence, it is sort of obvious that essentially when we talk about memory, it is being constructed. But again, there are lots of theories, lots of challenges, lots of arguments going on around that. But then what is learning? And then eventually when we talk about unlearning, we need to understand that learning essentially does include a part of memory. So when we talk about encoding and storage of human memory, that is the acquisition and storage, acquisition of information in your brain. And whether you store it as a whole or a little bit, then if this acquisition of information leads to a change in behavior, knowledge, or brain function, then it becomes learning. So learning is an application of a part of memory process. And we'll eventually see if what we learn, does it stay, or does it ever get erased, or does it get changed, or what happens with this information? Because I told you that brain has got a massive amount of storage capacity, 2.5 million gigabytes. But if you look at the fact that we store information every second of our life, and if you look at 365 days of about 70 years, you might actually hit the spot and you might go to the limit of your memory. Hence, you might want to think that maybe there's a different way in which the information is processed in our brain. And essentially, to learn something new, you might want to unlearn something that you've already learned. And that is what we're going to discuss today. So talking about memory and learning, there is a massive classification and lots of debate around that as well, by the way. So essentially, in a very general aspect, memory can be classified as a long-term memory, or it could be a short-term memory depending on the duration of recollection. But there are other entities as well, such as working memory. Here in the graph, it says that working memory could be a short-term memory, but recent research has proven that working memory can be a separate entity, and it's not essentially a short-term memory, but working memory includes not just storage, but it also includes manipulation and updating of information. So it's a separate thing. However, it does contribute to learning, but there is so much more to learning when we sort of approach the classification of memory, because apart from short-term memory, when we look at long-term memory, then we've got declarative and non-declarative memory. So when I talk about declarative memory, so these are memories that you consciously recollect, hence the explicit nature of it. Whereas non-declaratives are when you do not really consciously approach towards recollecting that information, but it's more like a procedural, habitual memory that comes as a function for you. And then this subconscious, unconscious memory aspect is actually the non-declarative memory. And within declarative, then you would have semantic memory and you would have episodic memory. And then essentially episodic memory is nothing but like event-based memory that is very specific to a particular time and place, whereas semantic memories are factual when it comes to knowledge or concept, which doesn't really relate to any particular event that is specific to time and place. But that could contribute to the knowledge learning. But also when we talk about non-declarative memory, there's lots of habituation and developing motor skills. Then that comes across as learning too. So there could be conditional learning, there could be operant learning, or there could be non-associative learning as well. So essentially, as I said earlier, when we are defining what memory and learning is, so the encoding and storage when translated into acquisition of information, and then it changes and brings certain characteristics, certain traits, certain skills in you, it becomes learning. So I told you that there are lots of memory theories and learning theories around there. So just to give you an example, all these 4 blocks of images are different competing theories or models that want to explain how memory happens, how learning happens. So on the top right corner is the memory localization theory, in which the focus is around engram cells. So a lot of researchers talk about engram cells as the memory information. So these cells store the information and they're called the engram cells. Whereas if you look at the diagram below it, it has multiple trace theory or the consolidation theory, in which essentially a part of your brain has a trace of information, not essentially the full memory, but a trace of it. And what happens is if these traces, when combined together, eventually lead to construction of memory. So there's multiple trace theory. A recent expanding theory, you would say, is transient trace theory. A lot of information in this theory is about the localization of memory function as well. So memory trace theory focuses quite a lot on hippocampus of our brain, whereas engram cells, like they could be a part of memory trace. Lots of scientists think that engram cells contribute towards memory traces, but some would just let it be neuron and not really talk about engram cells. So hence the argument, hence the discussions around it. But then what about construction? Is there a model that helps you construct, like gives you an idea how memory is constructed? So that is when a theory called self-memory system, so SMS, model theory is about how we potentially extract these information, episodic information, which could potentially be the information in the memory traces, or it could be the information in the engram cells, whatever source it is. There are cues that activate these memories. So I'm referring to the image on the top right corner. So in the bottom row, you could see lots of small squares with some black squares. So those black squares are essentially the activated memory traces or engram cells that are based on cues, whatever cue was provided to you. So say, for example, 10 days from now, if you were thinking about this seminar and you would think, okay, wait a sec, there was this black and yellow combination, question mark and exclamation, around which theories were talked about. So if you would see a black and yellow visual somewhere, then if you do get reminded of this seminar, then essentially one of your engram cells or one of your memory trace was activated or is going to be activated in 10 days. And then that cue essentially then helps you build and construct, like there is a proliferation of cue elaboration in scientific terms, where one cue leads to another cue, and then there is the snowball effect of creation of a bigger cue, and then eventually leading to construction of a memory. And what you see in the bottom right corner is something really interesting, something that actually won the Nobel Prize in 2014, and it is related to place cells and grid cells, which is very specific for spatial memories, spatial navigation. A lot of experiments were done on mice, and what happened was, to assess the spatial navigation, they would create a task, and then based on how they navigated through that space, they would see that there's this grid-like pattern of activation in your brain, and then eventually that leads to either habituation or either a conscious recollection of the spatial location, and then that then relates to the spatial memory. So again, you could see that there are lots of theories, everything trying to explain somehow how a memory is being recollected, remembered, or constructed. But what is common in all these theories? So the common thing between these theories are plasticity. So given the fact that we've got so many neurons in our brain, and you saw the connectogram that it was intertwined, so intertwined that it becomes really hard to sort of pinpoint the exact connectivity. And it's not just spatial, but temporal as well. So when I talk about spatial, as in location-wise, and when I talk about temporal is essentially in time. So there is plasticity not just spatially, but in time as well. So there's temporal plasticity as well. And it complicates even more, hence the complexity of brain. But this plasticity is what helps us construct memory or learn something. And potentially, this plasticity is what helps us unlearn as well. So that's kind of like the key element of the neuroscientific findings towards memory learning and unlearning, plasticity, neuroplasticity. And of course, when we talk about science, 40 years from now, science was derived out of philosophy. So it would be rude if I did not mention something philosophical. So that is why I would say change is the only constant, which is, I think, one of the penultimate truth. But yeah, moving on with the seminar, we talked about the complexity. Look at the video. So you could see lots of neurons, and then these bright sparks in these neurons, essentially nothing but impulses, the action potentials, the information that is being carried within the neuron. And then you could see how complex, how fast, and how diverse the information can be transmitted. Right? So I'm just going to let you see the video, enjoy it. This video was actually developed by Neuralink, the company by Elon Musk, who are one of the pioneer company in brain-computer interface. And action potential is nothing but the electrical or chemical impulses that traverses through the neuron to another neuron, and then eventually helps you perceive and then later relays the perceived information into some action. So again, back to neuron. So you've got a cell, the neuron, and it's got the cell body on the left-hand side. Then the long bit is the axon, which is, again, essential for transmitting the impulses. And then you've got the axon endings on the right-hand side of axon, which then, relays information. And this is filled up in the brain. But then our focus, again, would be towards neuroplasticity. How important is neuroplasticity? And in the video as well, you could see how complex the movement of it was. And it's really hard to have an algorithm to decode it yet. And I think there is a massive workforce right now trying to decode the whole human brain. And there are lots of computational neuroscientists, mathematicians, physicists trying to decode this information so that we could sort of enhance our approach towards not just understanding our brain, but what are the applications of understanding our brain? What are the application of understanding, say, for example, how learning or unlearning happens? So looking towards a brighter future. Now, given the fact that we talked a lot about our memory, our brain, the learning process, I want to talk once again about one of the theories or the models that are really like the self-memory system. So essentially, self-memory system, so that's the image on the left-hand side. It talks about the link between self, because I'm a researcher working on self-consciousness and memory, hence my interest in this memory. So we're not going to talk about the element of self, but we are going to rediscuss the element of construction of memory. Now that the image is a bit more larger, you could essentially see that the lower row with the small squares are nothing but information, the episodic information from any particular event specific in time and place. And then above that, if you'd see, there is general events. So general events essentially is more like, say, for example, birthday. Let's talk about birthday. Birthday is fancy. So say, for example, on my 20th birthday, I could remember quite a lot of details of 20th birthday. Then that would be the episodic element of that memory. But when we talk about general event, then general event would relate to birthday celebration. Lifetime periods was essentially then like talk about either if you classify it as like being an adolescent, then a young adult, and then an adult, and then eventually towards senile lifetime. But like these are the lifetime periods that you could classify. But of course, there are other classification as well, not just limited to that. And then eventually you talk about themes of life. And then so a single cue, like I said earlier, then triggers multiple other cues, snowball effect, the cue elaboration. And then essentially there's this updating and manipulating of information that happens, and then you construct something. But bear in mind, when you activate one particular information, the memory trace or the engram cell from this episodic information, it is not necessary that you would activate the same thing all over again and again, because what happens in brain is information is not stored as one particular thing, but it is stored in a modality. So related informations are stored. So one modality, say, for example, when we talk about traveling. So traveling could include road travel, or you could travel via a boat or something. But then essentially traveling comes across as a modality. But if you trigger one of the elements of, say, for example, travel modality, then it could potentially further trigger different other information that you might have stored in your brain regarding other travel events. Hence, there's a chance that you could expand on that and how the triggering happens. It is not always necessary that you would remember exactly the same detail. And I think you would all have noticed in your own conversation. Say, for example, all of you, at some point, you were at a pub with your mates, and then you wanted to talk about a particular hilarious incident. But is the incident always the same? Ask yourself. Not really, because I think I've got 10,000 different versions of one of my incident, and I always end up talking like different aspects around. And then I think, wait a sec, why did I not remember it the last time I was talking about it? So hence there is this chance of updating information, having a different sort of memory construction, or rather, like at some point, it's not even like construction of what was recorded or stored. But sometimes you could confabulate information. You could create false memory, and you could completely go bonkers and then talk about, yeah, like I was traveling in a yacht, but I never really traveled in a yacht. So yeah, that's a confabulated memory, but that happens as well. So it again focuses on the element of neuroplasticity, and that is something that I wanted to focus on for my experiment as well. So while researching the link between bodily self-consciousness and autobiographical memory, I conducted a research during COVID times. So the experiment was conducted completely virtually with people participating in Zoom. The experimental manipulation that we did to rekindle childhood memories was to create ownership for a younger phase. So what we did was, by creating an illusion of ownership of a younger phase of the participant, we triggered some information in the participant. And what happened and what we saw, as you could see in the graphs, should have had a more zoomed version of it. But if you look at the bottom two graphs, so you could see that there's a child face filter and no filter. And you could see the quality and amount of memory that was recollected when the participant had child face filter was quite a lot compared to when the participant did not have a child face filter. And when we further researched and saw that, wait a second, like we are talking about childhood memories right now, and surely childhood memories with childhood face, younger face, was enhanced. But is it the same trend that you would see in recent memories as well? Because in recent memory with childhood phase, if you recollected better memories, then essentially my hypothesis was wrong. But what we found was that for recent memories, not for childhood memories, for recent memories, there was no difference between child face filter versus no filter. So what happened was the skew of younger phase facilitated specifically childhood memories. So essentially, it somehow facilitated the participant to go deeper or like recollect better childhood memories by a mental time travel that they could create based on this cue of having a childlike face. And this research was actually awarded at Body Representation Network conference that happened in Sion this year. And we're really happy with the feedback and the responses that we got, that it could potentially revolutionize how we see memory recollection and plasticity. That, sometimes it is not essential that what you forget is essentially erased. So we're going to come to unlearning, and we'll talk about what are the elements of it. But just a little teaser that forgetting is not essentially erasing. Sometimes it's just changing. So essentially, if you trigger the right things, you would potentially then recollect something that was forgotten. Or if you trigger it in a very specific way, then there's a potential chance that you could change what is recollected. So you would potentially, in theory, unlearn the prior version, but you would learn a different version of what you're recollecting, of what information was stored. So yeah. Now, because we talked a little bit about forgetting, have a think about what is forgetting. So is it an error? Or is it an adaptive mechanism? Or is it an intentional action? Or is it a little bit of everything? So for ages, what researchers thought was forgetting was essentially nothing but our lack of capacity to store information. So it's essentially an error in sort of storing. So we were incapable of, storing it for longer duration, and that is what led to forgetting. But then recently, quite a lot of research, not quite a lot of research, but few research have taken a different perspective to forgetting. And they essentially say that forgetting is not essentially an error. There can be few elements of information that you can store properly or recollect properly or trigger properly as an error. But brain itself, given its capacity that we discussed earlier, brain can have this inherent adaptive mechanism of forgetting to essentially create a more sane space in our brain to sort of help us be more creative, recollect something else, learn something else, be more innovative. There is a big wide world ahead, given the fact that adaptive mechanism can help us create anything that we want. Hence, unlearning could be really important here. So we talked about error, forgetting as an error. We talked about possible adaptive mechanism that leads to forgetting. But what about intentional action? Sometimes you might have experienced something traumatic. Sometimes you might want to intentionally forget something so that it doesn't hurt you. Or like there might be certain situations that you just wanted not to have that as a part of your life. Then you intentionally want to get rid of it. So how do you get rid of it? A very common response by people is distract yourself. So you're going to stick to distracting yourself. So what essentially happens in distracting is you intentionally slightly change the scenario. You distract yourself to something else and hope that you would not remember what you do not want to remember. And then eventually in time, if you keep distracting yourself, there's a potential chance that the trigger is not happening properly to help you recollect the unwanted memory or learn the thing that you learned. But alternatively, the intentional distraction then becomes your newly learned action. So what I believe as a neuroscientist and a researcher is that forgetting is a little bit of everything. So, like given the fact that brain is so complex and plastic, I strongly believe that it's not just one thing of the three that I mentioned here. It cannot be just error. It cannot be just an adaptive mechanism. It cannot be just an intentional action. So a very recent publication, and in one of the prestigious journals as well. So it was in Nature Reviews Neuroscience with an impact factor of over 25. They said that all forms of forgetting, whatever happens towards forgetting, involves circuit remodeling. That switches engram cells that we discussed earlier from accessible to a non or inaccessible state. So again, the focus gets back to plasticity. So what I'm trying to bring your attention to is the fact that you can potentially have the power to modulate your brain. You can have the power to modulate your own brain to do certain things, to learn, unlearn, make an impact. So again, you are empowered with your own powers. Yeah, philosophical again, sorry. But yeah, then thinking about unlearning, because we discussed what forgetting is, we discussed what learning is, but then when we talk about memory and a part of memory being a contributor toward learning, which then results into certain behavioral change or skill, then what is unlearning? Like if you think about it from a very simple perspective, if you could learn something, you could definitely unlearn something. And given the fact that forgetting is not essentially an error, it's an adaptive mechanism, and it could potentially be an intentional action as well. So wait a sec, what is unlearning? Is it really like helping ourselves intentionally do something better? Or is it somehow subconscious, involuntary adaptive mechanism that helps us live better? because, brain is full of surprises, and you might be surprised how our brain helps us in every single second of our life to function properly. So again, there was this amazing book written in 1993, and a chapter of it, Unlearning Through Experience by Angela Hu, came with a very philosophical conclusion. And it said, unlearning is about being prepared to throw out what one has learned and begin afresh. And going back even more philosophical, the highest point of knowing is not knowing. So ask yourself, is there a treasure right in front of us? Is unlearning the treasure that we are seeking to have the life that we want to? Give it a thought. But then why you think about it today, tomorrow, in next 10 years, whenever. But for now, let's talk a little bit about neuroscience of unlearning as well. So when I was talking about the theories of memory, I mentioned an area of brain that was hippocampus. So on the left-hand side, you could see the sagittal and the other aspects of brain as well. And the brain that is, the part of brain that is marked as red on the left-hand side, that is hippocampus. And hippocampus is one of the most essential brain parts for memory. And there are lots of research, whether it's spatial memory, whether it's autobiographical memory, whether it's a factual semantic memory. A lot of it happens within hippocampus. And if you look on the right-hand side, just like very near to hippocampus is another small structure, and that is amygdala. And amygdala, like you might have heard amygdala as a part of brain that is responsible for emotions and fear. But research has now found that amygdala, with its functional connectivity with hippocampus and other neocortical regions, can actually be one of the neural substrate for plasticity and unlearning. So I think it was just a couple of years back when optogenetically, by induction of this amygdala with other neocortex, here the reference that I'm relating to, they had the functional connectivity with thalamus. But I believe that there is more functional connectivity of amygdala when it comes to learning and unlearning both. And I think like it is something that should definitely be researched. I tried finding papers, but I could not find if there is more expansive research on functional connectivity of amygdala with hippocampus and the neocortical regions. But for now, we could definitely see that there's a direction in which unlearning was experimentally induced in this example, just based on threat. So because amygdala has been researched quite a lot with fear, so they of course had this fear-based conditional learning that they induced. But then after the optogenetic manipulation, the conditioned learning was eliminated or changed, if you look at it theoretically, and then unlearning happened, and then they were able to sort of like not have that response based on threat or fear. But this is, again, just a teaser, because based on the functional connectivity, you could expand on other aspect of memory, not just fear, but say, for example, negative emotions, because amygdala is, again, very heavy with emotional affect. But you would then potentially see that you could expand to other cognitive functions as well. So you could think about executive functions, you could think about attention, because a lot of it depends on the connectivity. And if you would remember the image of connectogram, most of the brain parts are connected with each other. And it's the functional connectivity, not just the structural connectivity, that eventually leads to us functioning the way we function, learning the way we learn, or now unlearning the way we want, or subconsciously unlearn. So you can see that there is a neural substrate that we are already talking about when it comes to unlearning. And there has been some research about unlearning, and they try to classify it and try to like present what sort of unlearning there is when it comes to individual level. So the comparison, why I'm mentioning individual is because when you will look at literature, they compare individual unlearning with organizational unlearning. And organizational unlearning is very important because it builds on individual unlearning, but then it comes as a value for organizations such as hospital or an educational institution when it comes to organizational unlearning. But at this moment, I want to focus on individual unlearning. And one of the papers classified the types of unlearning as fading away, um, which is essentially like if you don't use an information, eventually you tend to forget, tend to unlearn that information. Then there is wiping. So what happens in wiping is related to changing. So it's not lack of use, it's the distraction that we talked about. So distraction can then talk about how we could unlearn a previously existing behavior, skill, knowledge into something different. So not essentially, dumping one thing in a bin and having a new thing, but rather like manipulating and updating something that you already have. And a lot of researchers actually believe now that it's more about this change rather than anything else. Like we always have information. If you look back to my experiment, the participants remembered more more childhood memories with a childlike face. So why did they not remember the memory when they had their adult phase? So essentially, they did have the memories stored somewhere in the brain. The information was stored there, but it was not being triggered. It was not being manipulated. It's not being changed or updated. But if you find a hack in your brain to update it, to change it, you could potentially, like I did, rekindle childhood memories, or you could potentially learn a new skill, or you could have a certain different behavioral change that you could apply on yourself or like the person you interact with. And then the other last bit that they classified was deep learning. So deep learning is like a sudden massive change in environment that led to something, and that massive sudden impact then completely overtakes whatever information that you had related with that previous thing, and then essentially you remember this sudden new thing and the deep unlearning. So essentially the impactful sudden unlearning of previous information. So these are the types that they've talked about, but this is not enough because these doesn't really talk about properly, at least, like, is the information being erased? Like what is happening with the information that we encode, we register while we are living? Is it always there in the brain? Like, is our pen drive in this skull? Is it really having that data all the time, or are we sending some information to the bin? Or is there an interference, like a distraction? Or is there a change? So we are not able to understand that yet clearly. Yes, there has been research done, but we do not have robust answers yet as to what exactly is happening. But from my perspective, if you look at the obvious, I would believe that information is there. And it's a lot about triggering so that you could then use the potential of neuroplasticity in your brain to unlearn and learn new things. So what do we take away from this seminar? I know that it is a very diverse audience group, and because this is led by HEMS, so I thought let's direct it accordingly. So I was reading an article about paradoxical education that is being applied in higher educational institution or schools, in which, because we have this stereotypical traditional educational system that is applied for ages, and it's really hard to change that. Some schools and institutions are now trying this adding the experimental approach that includes unlearning. So that's one of the benefit that you could potentially have from unlearning. in the educational system. And when we talk about healthcare and medicine, I will have focus on both individual unlearning as well as organizational unlearning as well. So it's not just the patients or the service users in healthcare and medicine, but it is also the service providers. It's also the nurses, the doctors, the paramedics. They all have to go through this transformative unlearning so that you're always up to date with new technology, new advances, new diagnostics. There's a constant transformation happening, a constant change happening, and you need to keep up with that. And hence, the transformative unlearning is very essential in healthcare and medicine. And then, like I was reading about social care and how unlearning could potentially be applied to social care. And then I found this Gotskin approach. So he was a Soviet psychologist, and he talked quite a lot about social aspects of psychology. And a part of his work was directed towards unlearning. And then recent researchers, they created framework around Vygotskin approach towards unlearning. And unlearning was then in social care environment related to not just social, but contextual and cultural aspect, all inclusive. And the change, the manipulation, that happens at all of these levels, not just at an individual level. Similarly, in healthcare and medicine, you need to have, so you would have some sort of unlearning at individual level, but the contribution of that individual level transformation needs to go for betterment of the organization as well, because organization needs to be managed well with new advances. So that is the importance of unlearning, the understanding that there is a massive plasticity going on in our brain, and you could use it to your benefit if given the right trigger and the right approach. However, because it is very under-researched and lots of research needs to be still done so that we could have more robust claims towards this, I think it's about time that a lot of neuroscientists should actually work on unlearning and create, of course, there'll be targeted research that would talk about particular areas, but we need to do that now. But I talked quite a lot about from my perspective as a researcher, but what about my perspective as an entrepreneur? So as Joe introduced, that I am also a founder of a startup that is Neurogether. And essentially, Neurogether happened because when I wanted to connect with like-minded people, there was so much noise on existing social media platforms like Facebook or LinkedIn that we wanted to create a safe and better space with better resources. And that is where Neurogether came in. So anyone with interest in brains, not just professionals, but say, for example, someone with interest in brain sciences, or someone with curiosity regarding any neurological disorder, or a neurodiverse individual who would want to have a place, a voice to be heard. Neurogether comes into play there. And it's not just that, like we've of course developed a website and an app for it to connect, but we've also organized conferences. So in October, on 3rd of October, we organized the first annual conference where we talked about translating ideas, research into something that creates impact in the real world. We talked about the neuroscience of entrepreneurial mindset and about neurodiversity. And we provided opportunity for entrepreneurs to come pitch their idea and make their research or business idea into a reality. And they were awarded with a few support and, of course, a chance to pitch to investors as well. So, and it's not just Neurogether. Recently, I have been working on a brain-computer interface startup with a few colleagues as well, given the fact that I've been working on memory. So the other project that I'm working on is essentially creating a virtual illusion, virtual environment to create neuroplasticity, and then use that neuroplasticity to collect data for different neuro aspects, and then use that data via a brain-computer interface setup to then translate into neurorehabilitation. So as you could see, as an entrepreneur, what I want to share with you is that, yes, there is lots of research and lots of research that will be done in coming future. But research doesn't need to stay just as a research or a fancy poster in a conference or a fancy research article in a fancy journal. But your research, your idea needs to be translated that makes an impact for us. And as an entrepreneur, what I want you to take away from this seminar as well is that should you have an idea or a drive towards something, stick to that drive and put in all your effort to make an impact, because making an impact in the world is what matters, us for others and others for us. And then to create that impact, you cannot do it by yourself. You need a team, you need support system, hence the networking, hence the interprofessional nature of the seminar as well, I believe, so that we could all connect, we could have our brainstorming session. There could be some feedback, there could be some constructive criticism, there could be something that I did not think of, but if there's someone who could reflect on this and provide me with valuable feedback, we together can make an impact, hence networking, hence my invite to connect on LinkedIn with me as well. I would love to network. And then another thing that I've learned, because I've been working on NeuroGather for over 1 year now, it is all about perseverance and adaptability. So just like our brain, just like our neuroplastic brain, you need to exist. There needs to be information stored. There needs to be learning, but there needs to be unlearning and adaptability within your approach towards creating your idea, your research into a real product, a real application as well. So these are the three key takeaways from me regarding your entrepreneurial ventures. And with that, I would like to thank you all. And like I said, let's get connected. This QR code is for NeuroGather app. And if you want to connect with me on LinkedIn or NeuroGather app, I would love to connect on both platforms. And I would love to see us making an impact. And now I would be very happy to take any questions that you may have. Thank you.